Good morning, respected jury, mentors and fellow cohorts. I'm Arshbir Singh from Dubai, from GEMS Modern Academy.
I'm Ashman Das from Greater Noida West, Amity International School.
And we are presenting Vantage, an AI-assisted human factors audit tool for HMI screens, which are human-machine interface screens. In simple terms, it controls rooms, interfaces and identifies design issues that could increase operator workload or hide critical information. Our goal is not to replace experts, but it is find risky screens faster. Industrial control room screens often evolve over many years. Different vendors and teams add new colors, alarms, screens and buttons, and whenever new need appears. Over time, the screen becomes cluttered and inconsistent. This makes it harder for an operator to quickly understand what's happening, especially during an emergency.
Think back to the Bhopal gas tragedy of 1984, when thousands of lives were taken because a gas leak remained undetected. Or the Texas 2005 refinery explosion because operators failed to identify exceptionally high tower levels. The 2005 Buncefield mine depot explosion in UK also happened because of the same reasons. See the similarities? They all point to one direction. If the operators cannot get actionable information and key insights about the screens that they're working with all day, then the consequences are almost always catastrophic.
Currently checking whether a screen follows human factors standards often requires a specialized audit. This process is valuable, but it takes a lot of time and is only usually performed once every few years. Plants may have hundreds of screens. So many interfaces remain unaudited for long periods. We want to make this the first level of checking, making it more continuous and more affordable.
Our project has 5 main objectives. First, we look for information clutter. Second, color misuse. And third, alarm clutter. So basically combining all these 3, we estimate the cognitive overload that a human operator has to have when he is interacting with the human-machine interface screens. And finally, we generate a full-fledged report that a safety auditor can use to check what systems need more reviewing. Our system is based on 2 established standards. ISA-101 provides principles for designing effective industrial HMIs, such as using neutral backgrounds and reserving color for meaningful alarms. NUREG-0700, on the other hand, focuses on contrast, readability and legibility. Together, these 2 give our tool defensible basis for evaluating screens.
We group interface issues into 5 categories: color overuse, alarm clutter, information density, navigation clutter, and contrast and legibility. Together, these categories cover the main ways a control room display can overload or confuse an operator. Rather than giving only one vague score, the system identifies the specific type or design problem. The workflow is straightforward. First, a user uploads a screenshot, then which is interpreted with a vision language model, which is the Gemini 3.1 flashlight. Then this goes over the rule engine and it's also used on the ISA-101 and the NUREG-0700 guidance. Then the system calculates a risk score along with a heat map showing the concerning regions, and then it generates a full-fledged report, and so the input is in screen image and the output is an actionable audit summary.
Our method combines AI flexibility with a deterministic rule engine. The AI provides the reasoning layer to work with HMI screens that have never been seen before, but AI outputs can vary over different runs. Along with that, we have also implemented a deterministic rule engine based on the 2 standards that we mentioned, ISA-101 and NUREG-0700, to at least provide the user with some amount of deterministic actionable information, whether the LLM runs or not. Combining both lets us interpret complex screens while keeping the final assessment explainable and auditable. For the prototype, we use HTML and JavaScript for the front end, with the planned React and TypeScript for a more complete product. In the backend, we have planned to use Python and Fast API. The vision language models are made to be pluggable, so you can bring in Claude Vision, Gemini, or you can even use a local vision language model, and the tool works perfectly with all of them. OpenCV and HTML5 canvas can support image analysis, and finally the system can create visual heat maps and export reports as PDFs.
We want to be clear about the limitations. The current vision only analyzes static screenshots, so it cannot observe live interaction or changing process conditions. Our validation is set small and yet the vision model outputs can vary across the runs. Most importantly, this tool is not a replacement for a human certified factors audit. It's a screening tool that helps prioritize expert attention.
Our next step is to connect the system directly with SCADA and DCS systems, enabling real-time rather than manual analysis. We also want scheduled monitoring across an entire plant screen inventory. For sensitive industrial environments, on-device model could support air-gapped and fully private deployment. Potential applications include power, oil and gas, chemical, water treatment, manufacturing, pharmaceutical, and mining facilities.
To conclude, Vantage offers a cheaper, faster way at looking industrial interface quality. It flags the screens that may need expert review, helping organizations keep up with interface drift over time. It does not replace specialized or formal audits, but it can make the process more frequent, more targeted, and more practical. Thank you.
Now for the demo. So here we have our demo. Just a second. Yeah. So as you can see, I can upload any HMI and SCADA screenshot. So let's say I have this one that I downloaded. If we click on Analyze screen right here, then you can see that right now the AI is reasoning. And right here we have the entire compliance score, risk score, cognitive load, and the numbers along with that, along with a full detailed report and actionable information. Along with that, we also have a contrast grid that can show grid-wise contrast in the image and help identify contrast areas more. Apart from that, we do realize that manual interfaces can be so we have a batch auditor too. So let's say I can upload several images all at once. If I open these up and click on Start Batch Audit, so right here we can see that it is parallelly processing all these 4 images that I have uploaded to make the entire process more seamless and convenient. Yeah, so as you can see, we have a report for all the images that we uploaded. And to top it all off, we also have a Save Batch to History button. So we can track all improvements that we have made in our HMI screens, and we can see historical trends here. Right now, I have some seed demo data that I can insert on my screen. So to show you, this is somewhat of the graph that we generate using the backend to show how the systems have improved or degraded over time. That's it for the demo. Any questions?
Any questions? It looks to be a little abstract, but when you are working in today we are talking about a digitized hospital where a nurse sits in one place and monitors every patient. That can be one scene. Or when you're working on a process industry, everything shows on a green light, red light button. Or when you're trying to regularly track a train sitting in the control room. So all these places, this one becomes very, very useful. So process industry, completely what happens is few of the engineers sit in a backend, monitor only the screens. So there this will be very, very useful. Right? Even for example, if your principal sits in her room or his room and he wants to see what is going on in multiple screens, so he can also put this to some extent, customize it, and he can find out. And he can find out where are classes where students are more involved with the faculty or with the teacher, where there is very passive. So all these things can be quickly figured out. Right? Nowadays we use cameras, online cameras, right, for monitoring what is going on in my house, office. There also you can use. And the interesting part is they have used 2 standards. So they don't say it is good or bad. They say my good or bad is based upon the standard. So the standard is already available.
Right now we have used only 2 of the many standards available because we wanted to reduce development time. In the future we can also implement more standards for a wider availability of audits.
Currently these 2 standards are the most generalized ones which
you
use currently.
Correct. And the same thing can be used in while playing video games. Like you are doing a simulator, there also it can be used. And live on a plane, that is also can be used.
Currently we're targeting this to the most of these factories.
Yeah.
All factories have these control room screens.
Correct.
And it gets pretty confusing, right? So that's why we want to make this, we want to make the operators life easy. So making it easy for them to understand what's going on over there.
Okay, let's congratulate if there are no more questions, sir. No more questions? Good.